This is Learning Assessment Problem 10.1. The problem-solving strategy here is that of magnetically coupled circuits. In the circuit in the problem, we have two inductances, L1 and L2, which are coupled by a mutual inductance term, M. And we are shown two currents, I1 and I2. We are asked to determine the expressions for the voltages V1 and V2 induced by these two currents. We'll notice that the currents I1 and I2 enter the undotted terminals of the two inductors, and this means that the mutual coupling or mutual inductance term will have a positive relationship to those currents and the self-induced voltages across L1 and L2. So we'll consider first the voltage V1 of T, and that is induced by the current I1 of T flowing through the inductor L1. So we'll have an L1 di1 T dt term. Then we have to consider the mutual coupling of the effect of the current I2 in the circuit. As we previously indicated, both currents are shown entering the undotted terminals, so we will have a plus M di2 T dt term for that voltage. Now for the second voltage, the V2 of T term, we notice that the current enters the end of the inductor L2 at the negative terminal of the labeled V2 of T voltage. So this means that we will have a minus L2 di2 of T dt self-induced voltage, and likewise the previous voltage V1 was indicated as having a positive mutual inductance term in its expression, so the mutual inductance will also be positive for this relationship, but again, because of the labeling of the current I2 and the voltage V2 of T, it will actually be minus M di1 of T dt.